Hello everyone, welcome back to our channel. I am your maths teacher CG ma'am. Today we are going to start with the last exercise of this lesson, that is 12.3. Here we are applying the formulas which we have discussed in our first video. Okay, that is formulas related to areas of circle. That is area of circle pi r square, area of semicircle, area of quadrant of a circle, then sector, area of the sector, area of the segment. All these formulas we are applying for this exercise also. Okay, so those who haven't watched my video, that is the first part, kindly please do watch that and understand all the theory sections very clearly so that this exercise also will be easy for you. So in the first question, here we have given a circle with the center O. Okay, and RQ is the diameter of the circle. Okay, diameter of the circle definitely passing through the center O. Okay, what we have to find out, the area of this shaded region. Okay, area of this shaded region. And a diameter of a circle divides a circle into two equal halves, isn't it? Okay, but in the shaded region, if you know exactly the shape of the shaded region, we can directly apply the formula for that. Okay, but even though these two are the segments, we don't know what is this angle. We have the formula for angle 60 degree and 90 degree, and you will get the area of the segment. But angle is not given and we cannot find out that angle also for this particular problem. So in order to find out the area of this shaded region, you can see a triangle in the half of the circle. This part of the circle, that is diameter, divides a circle into two equal parts, that we know. Okay, so if you subtract this area of this triangle, that is triangle QPR, you from area of the semicircle, okay, you will get to the shaded region, area of the shaded region. Understood? Okay, for that we should know what is the diameter of the length of the diameter. That means semicircle area is pi r square by 2. So there we need r, that is half of the diameter. Okay, so for that we have given, that is the length of PQ as 24 centimeter, okay, and PR is equal to 7 centimeter. Okay, and this triangle QPR will make a right triangle. Why? Because it is starting from this end point and ending from this end point, that is diameter. Okay, and this angle is in a semicircle, and we have learned in the last year angle in a semicircle is 90 degree. Okay, that means angle QPR, that means this angle will be 90 degree. What is the reason? Angle in a semicircle. In a semicircle is 90 degree, which means triangle QPR is a right triangle. Right triangle. I hope the reason is clear, because it is an angle in a semicircle. Okay, so it will be very easy for you now. That means if you subtract the area of the right triangle QPR from the area of the semicircle, you will get the area of the shaded region. That is what we are going to do in the next step. Okay, so in order to get the radius, okay, that means we should calculate this QR, that is the diameter of the circle, and but this diameter RQ is the hypotenuse of the right triangle QPR. Okay, so that you can apply Pythagoras theorem. Okay, by using Pythagoras theorem, you can easily calculate, that is the square of the hypotenuse QR square is equal to QP square plus RP square. Isn't it? So which means this is equal to, that is 27 is given PQ. That is 24 square plus 7 square, that is 576 square. I already told you should be very clear about the square numbers from 1 to 13, cube numbers from 1 to 10. Plus 49, on adding you will get 625. This is QR square. Which implies in order to get QR from QR square, you have to take the square root. So it will make 25 centimeter, and that will be the diameter of this circle with the center O. Okay, which means from this you will get radius is equal to D by 2, that is 25 divided by 2 centimeter. Okay, this is the radius. Okay, and we can write that very important step, that is according to the question, in order to get the area of the shaded region, okay, this is the formula, that is area of the shaded region is equal to, okay, this is equal to what I told, if you subtract that area of the right triangle from area of the semicircle, right, that is half of pi r square or pi r square by 2 area of the semicircle, right, minus area of triangle QPR. QPR is a right triangle. So area of right triangle whose length, base and height from this figure, height is QP or PQ, that is given, and base is RP, that also given. Okay, that is you can use the formula half BH, half into base into height. The next step we are going to substitute these values, and it is given that 22 by 7 for pi, okay, and 2 in the denominator, r square, r we have seen 25 by 2 into 25 by 2 minus half into the base is PR or RP, and that is given as 7, and height is QP, okay, that is 24, that also given. Okay, but we have found, in order to get this step, we have to find out, that is the diameter that we have seen by applying Pythagoras theorem. Okay, and the final calculation, okay, you look into the first term, that is this term, 2 and 22, 11 times. Okay, and in the numerator, that is 25 into 25, 625 into 11 divided by 7 into 4, 2 into 2 here in the denominator. So 28, 7 4s are 28. And in the second term, half into base into height. Okay, and this 2 and 24, 12 times. 12 into 7, 84. Okay. So again you can multiply 625 into 11, 5 2 6, 5 2 6. So 5, 7, then 8, 6. That is 6875 by 28 minus 84. You need not get reduced this first term, okay, then you have to multiply, cross multiply, that is 84 into 28, the whole divided by 20, that is the next step. Okay, so in the next step you will get this, that is 84 into 28, okay, that is 32, 3 carries, okay, that is 8 and 64, okay, 8 and 64, 72, 75, okay, 7 remaining, okay, then 16 and 7, that is 23, 23, 52, that is 6875 minus, I hope this step is clear, just doing the cross multiplication, and by multiplying we have seen their product is 2352, then whole divided by 28. Okay, by subtraction, okay, 6875, okay, 3, then 2, 5, 4, that is 4523 divided by 28. This is the area of the shaded region. Okay. So, after getting the final answer, you have to write down the unit. Okay, since PQ and RPS given in centimeter, okay, and the unit will be square centimeter or centimeter square. Okay, this is the final answer. I hope this is very clear to you. Okay, thank you. We are moving to the second problem. Here in this question, we have given two concentric circles with radii 7 centimeter and 14 centimeter. That is, the radius of the inner circle is 7 and the outer circle is 14. And they are concentric circles having same center. Okay, we have to find out the area of the shaded region. And the angle between the radii of both the circles is 40 degree. That also given in the question. Okay, so from this you just look into the first, that is the inner circle. Okay, so this is the region enclosed by 2 radii and its corresponding arc. This is the region. Okay, and with respect to the outer circle, okay, the region enclosed by this 2 radii, that is 14 centimeter. Okay, radius of 14 centimeter, that is the outer circle radius. Okay, and if you subtract the area of this portion, that means that is the area of the sector, that is a small part from the inner circle. Okay, so I am going to mark this as okay, CD. Okay, that means if you subtract the sector, area of the sector AOB, that means this portion from, can you consider the COD is a sector of the outer circle, because that OC and OD are the radii of the outer circle and the CD is the corresponding arc. So, definitely that is a sector of the outer circle. Okay, so in order to get this area, shaded region, you have to subtract the sector from the smaller circle, that is AOB. Okay, so that is the step, and if you substitute the values, you can easily calculate the area of the shaded region. Okay, so area of the shaded region A is equal to, okay, that is area of the sector that is COD minus area of the sector AOB. Okay, both having same angle, okay, at the center, that is 40 degree. And what is the area of the sector, children? Theta by 360 into pi r square. Radius, both radii are given, that is you can take small r, that is radius of the inner circle 7 centimeter, and capital R is equal to 14 centimeter. So we are going to substitute the formula here, that is theta by 360 into pi capital R square, outer circle sector, okay, area of the outer sector, minus theta by 360 degree into pi small r square. From both the terms, theta by 360 into pi can be taken outside, they are common. Okay, that is theta by 360 degree into pi can be taken outside, and r square, capital R square minus small r square. Here you can apply the identity a square minus b square is a plus b into a minus b. This is a square minus b square. Okay, so that is capital R plus small r, that is 14 plus 7 here. Okay, and 14 minus 7. and theta you can substitute as 40 degree by 360 degree into 22 by 7, that also given, and 14 plus 7, okay, into 14 minus 7, and this becomes 0, 0 get cancelled, 4 in 36, 9 times, okay, so 22 divided by 9 sevens are 63 into 21, 14 plus 7, 21 into 7, 14 minus 7. Okay, this is the last step. Okay, then 7 and 63 multiples 9 times, and 9 and 21 we cannot cancel. Okay, so this will be multiply 22 and 21, 22 into 21, that is 2 and 4 and 6, okay, 462, okay, this 9 divided by 9. Okay, so this is the area of this sentence, and we can reduce this. Okay, with 3, I think you can reduce with 3 because some of the digit multiples of 3 are. So 3 in 9 3 times, and in 4 1 time, 1 remainder, and in 16 5 3s are 15 and 1 carries and 4. So the reduced form is 154 divided by 3 centimeter square. This is the area of the shaded region. Okay, I hope this problem also very clear to you. Okay, the only problem is you just subtract the inner sector, area of the inner sector from area of the outer sector. Capital R and small r are both are given, so it will be very easy. Okay, now we are moving to the next problem. In the third problem, we have given a square of side 14 centimeter. Okay, we have to find out the area of this shaded region if APD and BPC are the semicircles. Semicircle means this PAD and BC are the diameter with respect to the semicircle. With respect to the square, both of them are the sides, and sides are given as 14 centimeter. Understood? Okay, so from the figure it is very clear because this is the third problem we are doing. The only difference is the shape. Okay, the concept is clear. If you subtract the area of these two semicircles from the area of the square, isn't it? You will get area of the shaded region. Okay, this P is a common point. This is a point on the semicircle. Okay, and the other semicircle BPC. Okay, BC and AD are the diameter with respect to the semicircle, and with respect to the square, both of them are the sides. Okay, so in order to get the area, we are writing the step, and finally we can reach into the answer correctly. Okay, so we have given a square of side is equal to 14 centimeter, and that is equal to diameter or AD, okay, and the diameter of the another semicircle, the second semicircle, that is BPC, that is BC. All the sides are equal because it is a square given. Okay, so area of the shaded region A is equal to, okay, area of the square, that is side into side, that is S square, minus area of two semicircle, that is 2 into, we know that area of a semicircle is pi r square by 2. Okay, so if diameter is equal to 14, implies r is equal to 14 by 2, that is 7 centimeter. Okay, the next is we are going to substitute, that is 2 into pi r square by 2. This 2 get cancelled. Otherwise, you can easily get the sum of two semicircle will be the whole circle. Okay, because both of them having the same diameter, the length is given as 14. So that also you can write in the first step itself, okay, pi r square, but this would be better, okay, that is 2 into pi r square by 2. Okay, so next step is we are going to substitute, that is 14 square minus, what is it, 22 by 7 into r square is 7 into 7, that is 14 square is 196, 7 get cancelled, 22 into 7 is 154. Okay, then just subtract, that is 2, that is 42. This is the area of the shaded region. Very simple, but this question is asked, okay, for one year for the board exam question, okay. So very simple one. So those who especially have selected for basic mathematics can be, for those children this question can be expected for the examination, okay. Now we are moving to the fourth problem. Yes, in the fourth problem, this is the figure. Okay, this both shapes are shaded. Okay, we have to find out area of these two shapes, that is a combination. Okay, but it is given that this triangle AOB is an equilateral triangle. Okay, and a circular arc of radius 6 centimeter, okay, is attached with this equilateral triangle, okay, and we have, and the side of the equilateral triangle, that is AB is equal to OA is equal to OB, all the three sides are equal, okay, and that side is equal to 12 centimeter, and we have to find out the area of this combination of the figure. Okay, so it is very clear, it will be the area of the equilateral triangle AOB plus area of this circular, that is arc, that is or sector, isn't it? Because this is the area enclosed by these two radii and its corresponding arc. If you complete this portion, it will form a circle. Okay, and since it is equilateral triangle, triangle AOB is an equilateral triangle that is given. That means each angle is 60 degree. Okay, sorry, 60 degree. Okay. Why we are talking about 60 degree? Because I already mentioned, okay, that circular portion, that is area of the sector. That means you have to calculate theta. Okay, so that is the whole circle is 360 degree. If you subtract this outer region, okay, this is not included in the sector, that is 360 divide minus that is sorry. In order to get the angle of the sector, okay, you have to subtract 60 from 360 degree. Okay, that is theta is equal to 360 degree minus 60. Why? Because it is given that a triangle AOB is an equilateral. So each angle is 60 degree. Okay, that means theta is equal to 300. And area of the equilateral triangle is root 3 by 4 a square plus theta by 360 into pi r square. That is area of the sector plus area of the equilateral triangle. Okay, let us see. So A is equal to root 3 by 4 a square plus theta by 360 degree into pi r square. Radius is given. Okay, circular arc of 6 centimeter. Okay, that is the radius of the sector. Okay, so we are going to substitute. Okay, root 3, that is root 3 can be kept as it is, root 3 by 4 into side is given as 12 centimeter, 12 into 12 plus 300 divided by 360 degree into 22 by 7 into 6 into 6. Okay, so 3 times, so 36 root 3, that is 12 into 3, 36. I am not going to substitute the value of root 3, that is not given. If it is given 1.73 or 1.7, according to that you can substitute. Okay, plus 0 get cancelled. Okay, and here this 6 multiples 30 and 36 multiples of 6, so 5 times, and this 6 and 6 get cancelled. Okay, and this 5 into 22 is 110, 110 into 6, that is 660 divided by 7. Okay, this is the area of this, the combined figure, that is this many centimeter square. Very simple one. This question also a board exam question. Okay, so the only problem is area of the equilateral triangle, root 3 by 4 a square, and how to calculate the angle, that is sector, angle of the sector theta, that is 360 minus 60. Why? Because equilateral triangle. Hope it is clear. Okay, now we are moving to the fifth problem. Now the fifth problem. In this question, we have given a square of side 4 centimeter. Okay, that is square ABCD having AB equal to BC equal to CD equal to AD equal to 4 centimeter. At each corner, a quadrant of circle of radius 1 centimeter is cut out, and at the center, a circle of diameter 2 centimeter also cut out. And what is the area of the remaining portion? That is what is asked. Okay, so see that which all things are cut from the square, that is 4 quadrants. Okay, 4 into area of the quadrant is pi r square by 4. 4 get cancelled. And area of the circle with the diameter 2 centimeter. So radius is equal to 1 centimeter. So pi, that is 22 by 7. R square means 1 into 1. Okay, so sum of these 4 quadrants plus area of the circle, that should be subtracted from area of the square. Then that will give you the area of the remaining portion. Is it clear, children? Very simple question. Only the matter is we have to substitute and get the answer. Okay. So the area of the shaded region, that means the 4 quadrants. So area of one quadrant. Okay. Area of a quadrant equal to pi r square by 4, that is 22 by 7 into quadrant of radius 1 centimeter, that is 1 into 1, okay, divided by 4. Okay, so what will be the area of 4 quadrants? That is 4 into 22 by 7, okay, divided by 4. That is 4 get cancelled, that is 22 by 7. This is the area of 4 quadrants since radius is 1. So 1 into 1 is 1 itself. So 22 by 7. And also a circle of diameter 2 centimeter. So its radius will be 1 centimeter. Okay. So diameter of the circle is 2 centimeter implies R is equal to 1 centimeter. Okay, therefore area of the circle, okay, that is pi r square, that is 22 by 7 into 1 into 1. So this also 22 by 7. That is, this is the area of 4 quadrants and this is the area of the circle. Okay, and what is the final step? Area of the required region. Okay, that is area of the shaded region is equal to, and what is it? That is area of the square. Area of the square can be written as side into side, that is s square, okay, minus from this square area you have to subtract the sum of the areas. Okay? So sum of, that is 22 by 7, this is the area of 4 quadrants, plus area of that circle, that small circle also 22 by 7. Okay, so this is equal to, okay, side is given as 4, okay, that is 16 minus 4 square is 16 minus of 22 plus 20, because like fraction denominators are same, so just add the numerator by keeping the denominator same. So 44 divided by 7. Okay, then we can just cross multiply. So this will be 16 into 7, that is 42. 4 carries 112 minus 44 divided by 7. Okay, so on subtraction, okay, 4 and 8 to borrow, so 8, okay, then 68, okay, divided by 7. This is the area of the shaded region. It's quite simple again. Okay, so just subtract the sum of 4 quadrants plus area of that circle from the total area of the square. Very simple one. Okay, so take sufficient practice and perfect with your calculation part. Okay, thank you for watching my video. Thanks for your support and share this channel among your friends. Okay, we will meet in the next video very soon. Thank you, dear children.